Okay, welcome. Just kidding. This is the questions that we had in class, the county test that we took on the computers a few weeks ago on the IBTP platform that I wanted to go over because it's a good review for your test. If you're absent and watching this is worth points. So make sure you watch the whole video, write everything down, turn it in, you can get the packet from me. Alright, on the first one, the population of a town after 1990 can be modeled by the expression, I think that's an L, maybe an I. I think it's I times 1.045 t raised to the t, where t represents the number of years since 1990, and I represents the population of the town in the year 1990. Which expression represents the monthly growth rate? Okay, this is exponential growth and decay. It's on page 11 in your spiral. You need to go back and review that. That formula is not given to you on the FSA. There's also continuously compounded interest that has the E in it. Y'all remember E? A natural number. And that is page 27. That's when you have continuously compounded interest. That's a different formula than this. And you're probably going to see a question on that on the FSA. It's on page 27, and it's a different formula than this one. And that formula is not given to you on the FSA either. Okay? So on this one, the options that they gave me, they didn't fill in anything for population of the town. The rate, remember, is 1 plus the rate if it's increasing, 1 minus the rate if it's decreasing. So since the number is all greater than 1 for each one of them, we know it was increasing, which is not what the question's asking, but just review. Now, to me, I thought this one was a little bit confusing. The correct answer is D. T stands for your number of time periods, okay? So option D, 12T, means 12 time periods. But the question was asking about monthly growth rate. So since inside the parentheses there's that 1/12 to power to a power, 1/12 of 12 is 1, right? So 1 month. If it just had the 12T out there, that wouldn't work because that'd be like 12 months. But because it's 1/12 of 12, that's just for 1 month, right? I thought this was very similar to B. Honestly, I can't give you a good explanation of why they're different. I'm guessing because this is 1/12 of a time period, and then raised to the 12. To me, they're very similar, but D is the correct answer. Okay, go back and review those. You can move if you want to, so you can see around me. Okay, 2 is the same kind of question, or it's based on the same formula. So page 11, exponential growth, exponential decay. And from here on out, I'll write these down. I just had that one up there already. All right, the value of Amy's car depreciated. So does that mean the price went up or down? Down. Each year, the expression K times 0.88 raised to the T represents the value of Amy's car after T years. So we know T is in years. What is the rate of depreciation? So remember the formula. Y equals A. A is the initial amount, or like the initial population. 1 plus R, you're adding if you're increasing. You'll subtract the rate if you're decreasing. Raised to the X, which is your time periods. So the formula they gave us is K times 0.88 raised to the T. They're not asking what the value of the car is after 2 years. They're just asking what is the rate of depreciation.
I have the wrong packet. I don't have any of these questions.
Oh, bring that to me. Okay. They just want to know the rate of depreciation. So depreciation means it went down, right? So that's why this number is less than 1, because it depreciated. So you 1 plus the rate if it increases, 1 minus the rate if it decreases. Well, obviously they already did the 1 plus or minus the rate and got 0.88. So how much did it decrease? What must have we subtracted from 1 to get 0.88? 0.12, right? Now A is 0.12%. 0.12%. Is that correct, or is C correct?
C.
C, it went down 12%. If that was just 0.12, okay, but 0.12%, not okay. So it'd be C. Coolio? If this was 1.12, we would know it would have appreciated 12%, not depreciated. Number 3. So we probably won't get through this whole packet today, so I'll just probably do like a half and half. We'll just see. I think we're out here at 11:52 today. Number 3, as x increases without bound, that means like your x is going to be increasing and there's not like an asymptote that's going to stop it. The graph of which function, we get that. The graph of which function rises at the fastest rate. So rises would be your y-axis, right? So which one rises at the fastest rate? So what I did is I just took each one of these functions and made a table of values with a calculator. And I just compared them to see which one. And at first, if I wouldn't have gone further, if I would not have investigated further, I would have picked the wrong answer. Okay? But then I went back and just decided to plug more numbers in, and then I figured out what the correct answer was. So what I mean is, like, I took A, and I made a little table of values. And I said, okay, when x is 1, what is y? So 3 to the first is 3. When x is 2, y would be 9. When x is 3, y is 27. When x is 4, y is 81. A starting point, right? I could add as many x and y's as I wanted to. So that was A. So for B, I did the same thing. And some of y'all may be able to look at the functions and answer, but I like to know if this is the FSA, I'm going to put the time into it instead of just thinking, which one do I think it is? I'm going to try to be a little bit more precise about my guessing. You know what I'm saying? For B, I plugged in x is 1, so 1 squared multiplied by 3. When x is 1, y is 3. When x is 2, y is 12. When x is 3, y is 27. When x is 4, y is 64. So the information I have right now, it looks like A, the y is increasing faster because when x is 4, y is 81. And this one, if I graphed it, when x is 4, y is 64. So far, it looks like A, right? Let's try C. This is a line because x's exponent, its degree is 1, so we know this is a line, right? Where this was a quadratic because the highest degree is 2. This is an exponential function because there's a variable in the exponent. So that might help you too when you're thinking about it. So for C, when x is 1, y is 53. When x is 2, y is 56. When x is 3, y is 59. When x is 4, y is 62. I'm thinking C is not going to be the answer, but I'm just going to look at all of my choices first. For D, when I plug in a 1 for x, y is 2. When x is 2, y is 17. When x is 3, y is 82. When x is 4, y is 257. So if I compare all of these, when x is 4, it looks like option D would be the answer, right? Because the y increased a whole lot more than the y on the other ones. So I'm thinking D's my answer, right? I mean, it seems like that's just going to be the winner. But just to check, I went back and picked a number like 10. I plugged in a 10 here. I said, let me just check 10. I want to go way down just to double check. Well, for A, when x was 10, y was 59,049. For B, I didn't even do B. For B would be 10 raised to the second power times 3 would be 300. For C, when x is 10, 3 times 10 is 30. 30 plus 50 is 80. Thinking C is not the option. And for D, when x is 10, so this is the one I'm thinking is the answer, y is 10,001. So D did not end up being the answer. It was, but then A would pass it, right?
Mm-hmm.
So put in a little extra time just to double check if that comes up. So A is 3. Shelby, will you give him one of those packets? Do you know which one it is? Everybody cool with that? What we're working on now? Yeah. Thanks. All right, number 4, we have exponential function. Remember exponential and logarithmic functions? We're talking back maybe September we worked on this. Definitely want to go back and review the notes and whatnot from logarithms, natural logarithms, exponential equations, all that stuff. And I think and change of base formula. That's definitely going to be on the FSA because that is one of the equations on the reference sheet. And this all starts around page 7. So that's literally one of the very first things we did. Okay? Number 4. What is the solution to the equation 3e raised to the 4t equals 60? E is a number. Remember, that's a natural logarithm, like 2.2, 2.6 something. So that's not what we're solving for. That actually has a number. T is a variable. That's what we're solving for. So our variable that we're solving for is in the exponent. So in order to solve this, we either have to write both sides with the same base, if possible, or we got to convert it to a logarithm. Okay? So I didn't even try to see if I could write both sides with the same base. I just converted it to a logarithm. But before I do, I have to make sure this is in exponential form. And it's very close, but it's not quite in exponential form. Because in exponential form, your base with the exponent equals something, okay? This base raised to the exponent is being multiplied by 3. So we got to get rid of that 3 because you only want your base, exponent equals something else. And then it's in exponential form, and then you can convert it to a logarithm, okay? If you don't remember this, remember Algebra Nation, go back, watch those videos, Khan Academy, whatever videos you can, the notes that we have, but if you need like verbal explanations, definitely watch videos. I'm going to make a little note here. Must be in exponential form before converting to a logarithm. Remember, exponential form is b to the y equals x. So your base to the y equals x. So like in this case, well, in exponential form, we need to get rid of the 3. So I'm going to divide both sides by 3. I get e raised to the 4t equals 20. So my base is e. My y is 4t. And my x is 20. And then a logarithm is written as log base b of x equals y. So in this case, that would be log base e of 20 equals 4t. Remember, we're trying to solve for t. Y'all remember if your base is 10, what that's called? Common logarithm, right? So you have a common logarithm. If your base is 10, they don't write the base, right? It's implied. Common logarithm base 10. Usually you'll just have a number down there, log base 2. You have to be most familiar with log base 2, log base 10, and log base e. Remember, if your base is e, that's called a natural logarithm. And natural logarithms you don't write as log base e. But I taught y'all to write it like we normally do. And then if your base is e, write it like this. That means the natural log of 20. That means that your base is e. Now, technically, we could find the natural log of 20 in our calculator. We have a natural log button. The calculator on the FSA has a natural log button. But if you look at your options over here, they don't simplify it that far. They all still have the natural log in there. So it's not necessary for us to figure out that the natural log of 20 is 2.995. If we actually wanted to know the actual what t is, we could find that, but they didn't do that in the answer choices. So we only have one more step really to get t by itself, and that would be to what? Divide by 4. Now, don't stop listening to me yet. I know the bell just rang, but I want to explain something important. Over here, this is t. Now, can I divide 20 by 4? No, because this is not 20 divided by 4. It's the natural log of 20. We already found the natural log of 20 is 2.99. Is 2.99 divided by 4 the same thing as 20 divided by 4? And no. So we can't do that. Now, if the 20 was to the left of the natural logarithm, that means 20 times the natural log of whatever. We could divide those, but this is the natural log of 20, meaning 2.9957, whatever it was. Okay, so our answer is the natural log of 20 divided by 4 equals t, which would be option B. I know we only got through 4 questions in like 30 minutes, but because I'm trying to remind you of all this stuff for the FSA, so I'm overly explaining, which is why I'm also recording so that my other classes can see it and I can make sure I overly explained and remind to them too. Okay? Good day.